teach one new topic. And which is actually pretty huge in the whole scheme of the AP test. But it's not that hard to think through. And then we're going to just review all of that first and second fundamental connections that we have, and then bring in all the stuff about increasing, decreasing, concavity, inflection points, and just show you that it was on the homework. If you've done some of these homework problems or some of the classroom problems that we missed, any of that stuff, the more you do, the better you're going to be. At some point, you'll feel like this is just the same problem over and over again. That's how I feel when I stare at them. I feel like I've done the same thing a million times. You'll get there if you do a lot of them. Also, there's a quiz tonight, a take-home quiz. There's also a homework sheet in your book. So if you want to do that, the keys are up for that, but it's not part of your assignment. So, again, if you're struggling today and if you're struggling with making connections today, maybe do that homework sheet and get a little practice. But here's the new thing that I want to do today. So what happens, and you might remember this from the very first week of class, I had it on your summer reading, but we also talked about it. If this is a function, do you remember this? If you have a function like, I'll call it f below, right here, then what did I basically do here? I took the what of this? You remember? This is the absolute value of that. And if you're looking at that and going, wait a minute, I don't remember that. It might have looked like this at the beginning of the year. If that's f of x, then this would be the absolute value of f of x. And if you really think about it, it makes sense. When I plug in x into a function, I get a y. Sometimes those y's have positive values. Sometimes they have negative values. Sometimes they have positive values. If I take the absolute value of the entire function, that makes every negative y a positive y. So it basically takes anything like this that was down below and flips it up above. So here's the problem for you. If I were to ask you to integrate this function right here from, say, -5 to 7, all you would have to do, like let's just say you didn't have this picture. You just had the function. You just pull out your integration rules. You integrate it to get the big F. Then you plug 7 in. And you plug -5 in. And you subtract. Now, yeah, you might take the step and write big F of x from -5 to 7. But the bottom line is you would be doing this and you would get some answer. Now, what your answer would be, guys, if you don't know this, your answer, and I'm going to kind of approximate this for you, but let's just say that this area right here represented a 7. And the area right here represented, like, I don't know, maybe a 6. And this would be a 7. Well, your fundamental theorem knows to make that part below a negative. So your total area between the curve and the x-axis is not going to be 20. It's going to be something like, and again, I'm making this up, something like 8. Because it just knows, the formulas know to make that part negative because it's below. It's a negative accumulation when you're heading to the right. Are y'all seeing that? Now, I don't know that it's 7 or 6 or 7. I'm making those numbers up. The point is, every now and then, you're not asked to find f of x. You're asked to find this. Absolute value of f of x from, say, -5 to 7. And you won't have this picture. So if you ignore the absolute value, what you end up doing is accumulating this area. And accumulating this area took that, whatever it was, 7, that -6 and the 7, and it spits out 8. But what you really wanted to do was accumulate positive and that positive, which is not going to give you 8. It's going to give you 20. Now, if you have a calculator, man, all day, if you have a 84, the absolute value button, if you need to take an absolute value of integrate an absolute value, get the integral on your screen, right? Math 9 put in your -5 to 7 or whatever it is, and then there's two places to get absolute value if you do not know where it is. But you'll need to know, all right? One of them is right above the catalog. Above the 0 button, there's a catalog. Catalog has every function in your calculator. So if you ever forget where they are, just go second, 0. And the very first one on the catalog is ABS parentheses. So you could type in the integral and then hit that button, ABS parentheses, and it throws up the absolute value sign. You type in your function, you put a little X in there, and it will spit out 20 for you. You cannot ignore this, okay? If you have an Inspire, which probably half of you have, and you turn it on, the easiest place I know to find absolute value is literally to the right of the 9. There is a button on one side, it has a book, and on the left side, it literally has absolute value on it. If you click that, it gives you this big window pops up. And one of the functions on there is the absolute value with a box in it. Mine's in the middle row, far left. If I hit it, you'll see an absolute value. On this, actually, you can also just type in A, B, S, parentheses. And if you do that and plug a number like -3 in there and hit enter, it literally changes it to absolute value -3. But the easiest way to do that is just to go find that on your absolute value button. Y'all with me? Oh, also on the 84, there's another place, including the catalog, to find it. If you go to math, there's a math button that has tons of operations. If you hit math, and along the top of that window, you see math, number, complex prob. Go to number, which is 1 to the right. So basically hit math, arrow to the right. Very first number 1 is ABS, absolute value. And when you hit 1, you'll see the absolute value sign there. Okay, so if you have your calculator, which you will on one part of the test, man, make your life easy, put the absolute value in there, and you're done. What do you do if you don't have your calculator? If I don't have a calculator, how do I find, if all I'm given is F, okay, if all I'm given is F, how do I integrate the absolute value of the function? Anybody have a thought? What would I need to know to be able to integrate from -5 to 7? Got any ideas, Lily? Where the function 0. The only place that this thing, when it switches, it only switches at the zeros, right? So if I'm doing an absolute value function, I need to know if this thing ever goes down below the x-axis. And if it does, it's going to do that at a 0 function. So all I got to do is take that function, set it equal to 0. It's probably a simple factoring deal. Or maybe you take out an x, or maybe you break it into 2 binomials. You just find out where those values are. And the great thing is sometimes those values aren't even on your interval. If I factor and I solve, and I find that this thing crosses the x-axis at 10 and 20, then I could care less about that. I couldn't care less, because at 10 and 20, I don't care about that interval. I care about when it crosses on that interval. And you can see, even if I couldn't see it, if I set that equal to 0 and I get -2 and 4, as breakpoints where it crossed, then that means if it crosses there, unless it's a double root, if it crosses there, some of that area is positive and some of that area is going to be negative. So here's what I would have to do at that point. And again, if I can't see this picture or this picture, I would have to come in here and say, okay, well, I'm going to break this up from -5 to where my first root was -2. But in doing that, I don't need absolute value anymore. And then I'm going to find the next interval from -2 to 4, and I'll show you how to do these. And again, I don't need absolute value anymore. And then I would find, because that's going to find this area. And then I'm going to find the last interval from 4 to 7, and that will find this area. Now, the problem is, do I know which area is above and which area is below if I don't have the picture? Well, hopefully you might know what the graph looks like. Like I know this. kind of graph is like, I don't know, x squared minus 2x plus 8. How about minus 8? What kind of graph is that, if that's a function? It's a parabola. Is it upward or downward facing? If it's positive 1. Upward? So if I know this is the function, and I factor and solve, and I get these two solutions, and I go, oh, well, that's definitely upwards facing parabola, then I know right now that if my interval goes from -5 all the way to 7, that this first one and the last one are positive values. So I can tell that this is a positive area. I don't need to mess with that. It's already positive. This is a positive area. I don't need to mess with that. But what is this going to give me? If I integrate it without absolute value, it spits out negative area. And if I'm trying to graph the absolute value, I don't want negative area. I want positive area. So what do I do to it to make it positive? Negate it. And this allows me to find and make all the areas positive. And that's what absolute value does. Now, if I have a picture of it, that's okay. I can see it. Right here, I can go, oh, integrate from -5 to -2, integrate from -2 to 4, integrate from 4 to 7. I can see that right there, if this was my graph, I wouldn't need to change the sign of this. But if all I have is f, I would need to change that negative area to a positive area, and I can do it by putting a negative in there. And by the way, if you had no idea what it looked like, if you didn't know, couldn't I figure out if the area was negative? And I'll do this by just picking a number in between -5 and -2 and seeing what the y value is. Like right here, if I plug something like -4 in my function, I'm going to get a positive y value. Oh, well, it's above the axis. Must be positive area. If I plug something between -2 and 4 into this function, I'm going to get a negative y value. Oh, negative y value must have been a negative area. Let's make it positive by negating it. I can always check that way. But this is a problem you're going to see. We're going to do one or two of them, or at least set them up. But they're tedious sometimes. I promise you will have to do this manually or with a calculator, either way, on your test. But on the AP test, this is how you're going to see it a lot. They're going to give you a question like this. And if you're taking physics, you kind of have a heads up here because you've seen this kind of mentality before. But this is how you're going to see this in physics. So let me just, for a second. They're going to give you a velocity equation. So let's just say they gave you something like, hey, the velocity is x squared minus 4x. Okay? And then they tell you how about this? They'll say, what distance what distance did Biff travel in the first 6 seconds? If this is his velocity measured in meters per second. What distance did he travel? And then they might turn around and say, what is Biff's location? Or they might say, what was his displacement? Now, if you take physics and you've dealt with a lot of velocity acceleration, a lot of this might make sense. But is there a difference between my displacement and my distance traveled? So the short answer is yes, but here's an explanation of why, if this doesn't make sense to you. Displacement means from my location, how far was I moved? How far was I moved from there? In the end. Now, I might go 10 feet that way, 8 feet back, 4 feet that way, and I am 6 feet removed because 10, -8, 4. Okay? My displacement would have been 6, or my location would be 6 feet from where I began. But my distance traveled would be what? Positive 10, positive 8, positive 6, 24 meters. So if you think about it, what did I essentially do to do distance? I took not only the positive travel, but I took the negative travel and made it positive. What does it sound like I'm doing if I keep the positives positives, but make the negatives positive as well? Absolute value. So when you see that word distance, you need to come up here and say, oh, if I already know that when I integrate a velocity, I get a change in my position, right here, this is a change in position, okay? That's what integration does. I could just integrate that to get the change in position or my displacement. But if I want to know what my distance is, I've got to integrate the absolute value function. And to do that, in the first 6 seconds from 0 to 6, if I don't have a calculator, I got to see, does this thing change direction? And guess what? What do I know here? I can do that by setting this equal to 0. And I find that, look, at 0 and 4, it went from a stop, right? At 0, it's stopped, no velocity. At 4, it stopped, no velocity. At those 2 points, I am changing my positions. 1, I'm starting. So I headed off actually negative, right? 0 and positive 4. So, positive 1. All this is positive. But once I hit 4, now I'm going the other way, aren't I? I'm sorry. Hold on, let me make sense of this. Yeah, it's negative to start. And then after I hit 4, then it's positive. Point is, if I were to do this and I wanted to find my total distance, I got to break up this integral. So I would have to say, wait, I would have to integrate from 0 to 4, because 0 is already where I began. 0 to 4, regular velocity. And then I would have to go 4 to where I ended of regular velocity. And then I got to decide which of those 2 areas was negative. And if I want to graph the picture of it, I'm fine. But if I'm not sure, pick a number between 0 and 4, like 2. Plug a 2 in, and what do I get? 4 minus 8 is negative. I had negative velocity. So negative velocity would have given me negative area. Let's make it positive by negating that negative. And then if I pick something between 4 and 6, like 5, 25 minus 20 is positive. So if that's a positive velocity, it's already above the x-axis. I'm going to get a positive area. I don't have to mess with it. And again, if I have a calculator, I am going to integrate that. I'm going to type it in my calculator with the absolute value sign over it. If I don't have a calculator, I'm forced to use the regular velocity, but I must consider where it crosses that x-axis. And then any place where it's below, I got to negate it to make it positive, etc. You need to look for key words like distance, displacement, location, change in position. Those are all similar in that it doesn't matter if I go back and forth and back and forth and back and forth. It's where I ended up. I'm looking at that change in position. That's displacement, change in position. The location, the only difference about location is location, you'd have to know your initial position and then add to it. But all of these, I don't need absolute value for. Distance, I do. Also, if you ever see the word speed, what is the definition of speed? Again, if you're in physics, you got a little bit of a heads up on this. Is speed the same thing as velocity? No. Speed is always positive. It's non-directional velocity. So if I say speed, you have to immediately do what? Absolute value of velocity. That's literally what it is. So when you see speed, make a mental note. Guys, you will see at least 2 or 3 questions on the AP test that have speed in it. And the second you see that, go, oh, that's that. So if they give you velocity, you better take the absolute value of it. And if they give you a picture like this and they ask you for area, if they give you a picture like this and they ask you for area, then you better be taking that negative part and swinging it up. Because if this represents a velocity curve right here, then this would be a speed function or an absolute value of velocity curve here. Are you with me on that so far? All right, let's just see if we can do a couple of these. We did this one, number one. It was super tedious. Let's do number two. I'll tell you, we'll set this one up first. So right here, I'm doing absolute value of that. I do not have my calculator. If I do have my calculator, if you type it in, I think you get 58.5. But if you have a TI 84, you get this. I think it was 58. Hold on. On a TI 84, you get this here. 58.499999988 or something like that. Sometimes your 84 and your Inspire will give you answers that are not fact. But our rule is you always round to 3 decimal places. Even when it's ugly like this, it should have spit out 58.5. But even when it's a little off, if you are rounding to 3 decimal places, it will be accurate. Are you with me? I mean, most of the time when I see that, I'm like, okay, come on. I know that that's 58.5. You'll get accustomed to that. But again, rounding will always get you the right value. And if it doesn't, they wouldn't have asked the question. So how would I set this up without a calculator? What do I need to know about this function if it crosses and gets below? Now, by the way, what if I saw this, right? I mean, what if I was going, just help me out with this problem real quick. What if I was going from 3 to 10 and I had x squared plus 5x plus 7? Do I need to bother checking to see if this thing crosses the x-axis? Tell me why or why not. It does not matter what number I plug from 3 to 10 in there, does it? No matter what I plug in there, this is going to give me a positive value. There's literally no way for it to be negative. Up here, when I look at it, I go, wait, I plug a negative in there, I get 4. Negative in there, I get 6. But if I plug something like 3 and 4 in there, I get 16. 4 in there, I get a negative 12. This can produce some negative numbers. I better factor it and see. But sometimes you look at it and you're like, wait a minute. There's no way this ever is going to give me a negative value. And if that's the case, then don't worry about it. Just integrate from 3 to 10. But when you start seeing negative values there, or maybe negatives in your function, it's probably a good idea to go ahead and set it equal to 0 and factor and see. So here's what I'm doing first. I see absolute value and I go, well, let me take the function, the regular function, set it equal to 0, factor, and I can easily see that it crosses at 0 and 3. So what that means is I have to break this up. Not -2 to 7, but -2 to 0, 0 to 3, 3 to 7. And on each of these, I'm going to integrate. This allows me to get rid of absolute value. I'm just going to integrate the regular function . Now, I want them all to be positive. How do I know which one's negative so that I can go back in there and negate it and make it positive? Do what? Well, they're all this, right? If I solve them, I get 0 and 3. What do you mean by solve? Now, yes, I can totally do that. If I integrate this from -2 to 0 and it ends up being negative, then definitely make it a positive. So you can totally do that. But you know what AP sometimes says? And I'll do it on my test. I know, because I don't want you to have to do this all the way. I'll say, set up what you would do to find the area. Like set up the expression. So I'm almost there. But how could you know whether it's positive or negative right now? There's 2 ways I can think of. Plug something in this interval. So what if I pick -1? -1, if I plug into that function, gives me +1 plus 3 is 4. That means this function on that interval is above. Well, that's positive area. I don't have to change it. If I plug in between 0 and 3, like a number like 1, if I plug it in there, I get 1 minus 3 is -2. That's below the x-axis. That's a negative area then. Negate what would have been negative to make it positive. And if you're looking at that and going, well, could I just switch those around instead? Isn't that the same thing? Because if there's a negative out there and I multiply it in there, it becomes -x squared positive 3x. So if you don't like the negative out there and you want to multiply it in, you can. I don't do that because I don't really want to integrate 3 different problems. So I'm just going to do one integral and write it down 3 times and then just have the signs waiting on them. And then the last thing, anywhere from 3 to 7, pick a number like 4. I get a positive number there, so I don't need to change that. And also, if you're thinking, Mr. Hurry, I know what this graph looks like. This is a parabola that crosses at 0 and 3. I know that. And it's a positive x squared, so I know it's an upward parabola. So if I'm integrating from -2 to 7, what do I know about this? It goes negative, a positive, negative, positive. So it's the middle part that I need to change the sign of. And if you know what graphs look like, and listen, most of the time they're using parabolas and junk like that. If you remember those rules, great. But you can always just check. So on your test, I might totally ask, set up what you would do, don't bother integrating. Y'all with me? Now I'm going to go all the way on this number 2 because it's a little more simple. Right here, same thing. Oh, crud, absolute value. Oh, parabola. Maybe it goes below, maybe it's above. I don't know. Let's see. So I take that right here. Take that x squared minus 3x minus 4. I set it equal to 0. By the way, if you stink at factoring, please get some help. It will really be costly on your AP test. 4, 1, negative, positive. So at -1 and 4, what do I not have to worry about? -1, it's not on my interval. So great, I don't have to have a bunch of integrals. I only have to have 2 integrals on this one. So I do have to consider the 4. So from 2 to 4, and from 4 to 6 of the regular function right here. And which one's negative? Well, if you don't want to sketch a picture of it, pick a number again like 3. So if I pick 3, I get 9 minus 9 minus 4. That's negative. So that means I need to gate that negative area to make it positive. This one, I plug a 5 in there, I get a positive number. I don't need to mess with that. So this is going to be kind of tedious. So literally, when I take the integral of this, I get x cubed over 3 minus 3x squared over 2 minus 4x. From 2 to 4, don't forget to negate it. And over here, I'm going to have the exact same function. But from 4 to 6. So I just got to start plugging and chugging. So this is what my math would look like. Fundamental theorem. Plug in the 4, plug in the 2, subtract them. Don't forget to change the signs when you're done. Then plug in the 6, plug in the 4, and then I'm going to add them. And then subtract them, and then I'm going to add that when I'm done. And that gets really tedious. Right here, you might have to, if you had to do that manually, I would probably make your integral be a little bit sweeter than that. That's just really terrible and ugly. But if you had to suffer through it, I get 64 thirds minus 48 halves. Yeah, we're not going to do this. Minus 16. Whatever I got there, I'm plugging it in there. Then I plug a 2 in, and I get 8 thirds minus 6 minus 8. And I take that, and I plug it in here. And I just keep doing that and clean it all up, and I'll get an answer. And again, AP as well as me will either say set it up, or they'll give you an integral probably that doesn't have tedious fractions. Or if it does have ugly fractions, it'll have intervals here. So when you plug the number in there, stuff cancels, and it makes it a little nicer to deal with. They usually are not killing you. Y'all with me on this? Okay, all I want to do now is go back and revisit what we've been doing. So yesterday we didn't get a chance to do a ton of this. I hope at the end of this problem you feel a lot better about it. But you tell me. All right, so this is page 120. I've got this big F is the integral of little f from 0 to something. So tell me in your own words, what are you doing to find, big F? Area of what? Area of little f. So right here, to find big F, that right there means area of little f. So right here in the first line, 1A, 1B, 1C, and 1D, all of those are asking for big F values. And big F values are areas of little f from 0 to whatever. First one's 4. So what is big F of 4 is the area of little f from 0 to 4. Here's 0 to 4. And what is that right there? It is a semicircle. Radius is 2. 1/2 of a pi r squared. So 2 pi. Done. You get no points for work on something like that. What's f of 6? From 0, I'm just getting that as well. What is that? The area is 2, but it's below, and you're heading to the right. So not only do I have 2 pi, but now minus 2. Now, for the C, I'm doing f of -1. I'm sorry, big F of -1. Big F of -1 is heading to the right. I'm sorry, heading to the left. That area is 1/2 base times height. That area is 1. But since it's above when I'm going left, it is negative. And big F of -3 is the area of little f from 0 to -3. Now, -3 goes to here. Anybody got any ideas for that? What do you notice going from 0 to -3 here about these two parts? They cancel. One's positive, one's negative. So if I'm wise, I won't even look at those. And I'll go, well, all I did from that -1 is accumulate another -2 because the other parts don't matter. So -3. Are you with me? Now, next row, big F prime. Now, big F prime can only be found by looking at this function and taking the derivative of both sides, which would give me big F prime. But when I do that, when I take the derivative of the left and the derivative of the right, the left side clearly is big F prime. What comes into play now for the right side? What is that when you see a derivative of an integral? That is the second fundamental theorem. And what does the second fundamental theorem do? The d dx and the integral do what? Cancel each other. What happens to the numbers like 0? You completely ignore them. And what do you do with the thing on the top? Two things. You plug it in to get f of x and then multiply by the derivative of x, which in this case is a 1. Very often it's not x, it's 4x, 10x, x squared. But in this case, the derivative of x is 1, so I don't have to bother. Now, what is this saying to you about big F prime then? Because you just told me big F was area of little. Now, what is big F prime? How would you describe that? What about it, though, specifically? The y values. Y values of little f. So f of x, little f of x means the y values of f, of little f. So big F prime is which is the slopes of big F, or the derivative of big F, means the y values of little f. So let's go. What's f prime of -4? That's the same as the y value of f at -4, which would be 0. Next one. Big F prime of -1.5 would be the y values of f at -1.5, which would be 2. Big F of 2 would be the y values of little f at 2, which would be 2 again. And big F prime of 5 would be the y values of little f at 5, which would be -1. Now that's also the slope at 5. You'll see in a second, but I'm down 1. Now, if I want, in 3, I wanted the second derivative of big F. Well, that's much easier because all I got to do is take the derivative of both sides. So how would you describe big F prime? Slopes of f, little f. So big F prime of -4, what are the slopes? This is a trick question. What are the slopes at -4? Well, first of all, the slope of that line is -2. Be careful. But what is it? It's D and E. Why? It's an endpoint. Right? Derivatives don't exist at non-continuous spots. Remember? Derivatives don't exist at corners, cusps, going vertical, or where it's not continuous. You have to know those 4 points of discontinuity. We'll review those again, but at an endpoint, it's not continuing, so it's not continuous. So there's no derivative there. So there is no derivative of little f there because there's an endpoint. So D and E. What about the second derivative at -1.5? Right, and -1.5 would be 0. Hey, while we're at it, what's the second derivative at -2.5? What's the second derivative of big F at -2.5? What's the slope there? 1, 2, 3, 4 over 1? 4? Just look at the line and go to 2 endpoints and just count the slopes. I mean, the rise and the run. So if I had asked you about -2.5, the second derivative of big F, you would have said 4, hopefully. What about the second derivative of big F at 2? The slopes of little f. And then what about the second derivative of big F at 5? -1, because it's going down 1 over 1, down 1 over 1. Y'all with me? That's like 3 points on your test. I mean, I think, if you got that down. Now, let's talk about what you remember or don't. If you don't know this, again, doing that extra homework worksheet would be a pretty good idea for you. If all of this is like, oh my gosh, I've forgotten all this stuff. Now, when anybody starts asking you questions about where a big F is increasing, decreasing, concave up, has a max, has a min, has an inflection point, anything like that, forget about the picture for a second and just think about your rules and write those rules out. That's what I'm going to do. And then the only thing you have to do after that is link big F to the little f function. And literally your link is right here. So if I ask you a question like I am in this first one about where f is increasing, that's going to be, you'll see in a second, that's going to link you here. Just state, oh yeah, big F prime is little f. And when you state that, they go, oh, they understand the link between this and the graph. If you don't link it, and all you talk about little f, they're going to go, why are you talking about little f? If all you talk about big F, they're going to go, I don't even have a big F function. You have to make this connection. So let's go back and look at number 4 right here. All right, so I'm going to shrink this down a little bit. All right, so number 4, here's my picture on the screen. It says on what interval from -4 to 6, on what subintervals from -4 to 6, here's -4, there's 6. Pay attention to that, by the way. Sometimes AP is really annoying. They give you a graph from -4 to 6, and they go, on what interval from -4 to 0? You're like, why do you do that? But do pay attention to the interval. -4 all the way to 6 is big F increasing. Now, forget about the picture a second. Where does a function increase? When it's what? When its derivative is greater than 0 or positive? Write that. So literally, I'm saying big F increases when big F is positive. Now, you could write where the slopes of big F are positive, or you could write big F is increasing, but don't say that because that was the question. But they all mean the same thing. Now, I haven't linked this yet. What was big F equal to? Little f. That's your justification. Hey, little f, which is the same thing as big F prime, is greater than 0 here. That is all you need to say for your justification. Now, the other thing is, well, where on this big F on this little f graph is that true? So what am I really looking for? I'm going to the little f function, and I want to know where is little f what? Greater than 0. And we already said little f were the y values. So where are the y values of f greater than 0? That's where the y values are greater than 0. I got to be honest, I normally don't write it like this. I normally write big F prime, which is little f, is greater than 0. So I can think about the graph. Oh, yeah, where are my y values positive? Now, if you're looking at this and going, Mr. Hurry, at 0, the y value is not positive. At 0, the y value is 0. So technically that's not true. I agree, but that's not what AP thinks, and let me show you why. So technically, f is positive from negative 2.5 to 0, technically, and then from 0 to 4. But do you know what the definition of increasing is? The definition of increasing means at any point, the y value to the left is bigger, the y value to the right is smaller. Now think about what's happening here. On my real big F function, which I do not see, what really happened was it increased, and then at one spot, it had a slope of 0. And then right after that, it increased some more. So couldn't you still argue that at that place where the slope was 0, to the left, the y value was lower, and to the right, the y value was higher? Yeah. So they're going to not take that. They're not going to write that as an answer. If I have it on my key, tell me, because in the olden days, I was putting that as an error. Sometimes people don't tell me about my keys, and I don't have time to look through all 3 classes all the time. Skip that and just go from negative 2.5 to 4. Are you seeing that? So over that whole interval. Now, if that was flat for a while, like if it came down and it was flat for a while and then it came back up, then no, don't include that. Because that would mean that this thing did this and it was slope was 0 for a while and then went up. Wait a minute. I know y value there. Is the one to the right bigger than the one smaller? No. But if it only hit 0 for one instant, skip it and go all the way through the end. So that is my subinterval, and that's my justification. All right, let's look at the next one. Similar kind of thinking. Where on that interval does f achieve its min? Now, yesterday, if you remember, we were talking about relative maxes and maxes. I think the question was relative max. All I had to do was check where the derivative was 0, and it went from plus to minus. This doesn't say relative min. It says what? Min. And when I'm checking mins or maxes, I also need to consider what? Endpoints. So don't forget that. So first thing, where on that interval does big F achieve its min? What is that min? Justify. So first thing, where do mins occur? Forget the picture. Where does a min of big F happen? And I'm going to write, well, I'm going to try to squeeze it in right here. Where does a min occur of any function? A min occurs when its derivative is 0 or d and changes from negative to positive. That would be a relative min, or what? Possibly at a what? Endpoint. Now, normally we don't even check the relative min. We just find critical numbers and endpoints and we plug them in the function. That's a lot of plugging in. So if I can eliminate any layouts or relative maxes, it might be nice. So I'm going to say, all right, where does f achieve its min? You could say f achieves its min here. I'm going to write my answer so that you have room to see it right here. F has a min when the derivative of f, link it to this picture, which is f, little f, is 0 or d or at endpoints. Technically, that's what I would do. Now, I got to be honest with you, on a real AP test, most of the time they're asking you about relative mins and relative maxes. But occasionally I do this. So this is, to me, a little bit extra thinking. Now, you might actually put, hey, 0 d and changes from negative to positive. All right? So where would it be? Again, I'm not doing this question. I'm doing number 5. Where would I have a minimum value? Where it's 0, where big F prime, which is F, equals 0 d and change the signs to negative positive, or possibly at endpoints. So let's see where that happens. What do you know about big of prime of F? It's little f. So where is this function 0? There, 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 even there, but that's going to be an endpoint. So I need to check negative 4, negative 2.5, 0, 4, and also 6, because that's an endpoint. Now, what can I eliminate? if it's a relative min, negative to positive, positive to positive, positive to negative. I know it's not that. That's a relative max. I know it's not that. That's a layout, positive, positive. That's a relative min at negative 2.5. And then those are endpoints. So negative 2.5 normally would be your answer here. So I'm going to say on what, where in the interval does that achieve its min? I'm going to say, I think it's negative 2.5 because I know that's a relative min. But let's just check the accumulation. If that's a min, a relative min, going back this way from negative 2.5 would accumulate what kind of area? That would be what kind of area? Positive area. Does that make it less or more? So that's definitely not the min, right? So this is smaller than that because that would have accumulated positive area. What if I go to the right to that endpoint? What am I doing? Accumulating a bunch of positive, even more positive. Now I am losing some negative there, but did I lose more than I had previously gained? So there's no way the endpoints are. So I can say, hey, where does it achieve its min? At that, because I checked the endpoints and I checked those. Now you could always say that that big F of negative 4 is greater than the big F at negative 2.5. And you could say also the big F at 6 was greater than the big F at negative 2.5. You can make that statement if you wanted to. Heck, you could even go and find big Fs. How do I find big Fs? I've actually already found 1, 2, 3. I haven't found F of negative 4, but I could find F of negative 2.5. I could find F of negative 4. I could find F of 6. I could do that if I wanted to and just show that it was smaller. Now, what is the actual min? What do I have to do to find that min of F? How do I find any min when I know the X value? Plug it back in the function. So what is, for the min, what is big F of negative 2.5? What would I have to do? Yeah, it's area function again. It's back up to like number 1. So I'm finding negative 2.5. What is the area of all of this? So I go back and find it, and I don't, what is that 1? I can't even see it. That ends up being 1, 2, 3, negative 3.5. So the actual min is negative 3.5. And I've already justified my answer in all these words. And I don't have time to do number 6, but let me just ask you, where would big F be concave up? Or the second derivative of big F? How would you justify that? The second derivative of big F is what? Is the derivative of F. And how would I know it's concave up? All of that would be what? Second derivative is positive. So what would you be looking for on this graph? Where it had positive slopes. These problems, guys, if you remember what you learned from prior in the year, which you guys are a pretty solid group. If you don't, man, go brush up on that because this is all over your test. Y'all have a good one. And don't forget that take-home quiz, guys. Say it again. Okay, so remember, like, if I know that there's a relative minimum F value right here at negative 2.5, right? I know there's a relative min. So I know that along this function of big F, it does dip down there. The question is, does anywhere else on this big F function, does it dip lower? Well, the only places where it can dip lower were other relative mins, which there weren't any, or endpoints. So what I could have done is just gone up here and checked F of big F is negative 4, big F of 6 and big F of -2.5 and seeing which one was the smallest. But another way of thinking about it is, think about it. The area here, to go from there to there, if I know this value and I go left on the area, the accumulated value of little f is big F. And if that area right there is, say, -2, I'm sorry, if that area there is 2, but I'm going left, bottom area is positive. So I have to add 2 to whatever it was at -2.5, which gives me a bigger value, right? The only way that this thing, like what if this endpoint, I meant to say this, but I didn't. But what if this graph did this? And your endpoint was maybe 15 out here. Well, think about it. At -2.5, I had a certain amount, right? I accumulate some positive. I'm checking the endpoint. I accumulate positive, but then I accumulate what? What do you think the min is? That. But guess what? If I were to go up here and plug in 15 and do it, the area I got there would be smaller than if I just checked f of -2.5. So you can always just go back and check those out. Sure.
Or can't you do it to Jackson?
That's the first thing.
We doing piecewise functions?
Taking a quiz, man. I don't know that we'll get the piecewise functions. I always like to have about 2 or 3 days at the very end, but it just matters on how things play out.
Unit circle? Or just?
That's actually a polar graph.
Okay.
We normally deal with X and Y coordinate planes, but there's also a polar.
Oh, we learned about that last year a little bit.
I mean, you technically know about it. If you look at the top of a globe, you have longitudinal lines that spin off from the pole. That's what that is, 360 degrees of longitudinal
No, I
lines.
think we just mentioned it. I feel like that looks familiar. How's your day so far, Mr. Perry?
Tired. Looking forward to a quieter couple of years. Hey.
Yeah.
And I miss
That's pretty good. Went over there to visit with Helmers a little bit.
Oh, it's the best. I need to visit Mr. Helmers. It's been a while since I've seen him.
Alabama plays Auburn tonight at Auburn. Oh, sure. I show more Alabama gear today.
You are.
It's crimson.
Crimson in gray, man. What are you talking about? You just didn't overpay for a logo.
Exactly. I can just kind of print one out and tape it on there.
That's right.
It's a blend.
You know, there's a UT kid, University of Tennessee fan, and I guess he was a poor kid. And have you seen this? And he didn't have a University of Tennessee shirt, but they were supposed to dress up with it. So he scribbled out this T or something, and pinned it to his shirt. And of course, he's in elementary school, so everybody, the bullies start mocking him and making fun of him. Well, the mom posts something about it, about how my son was bullied and blah, blah, blah. Well, it goes viral. And the University of Tennessee ended up, which is kind of cool. I don't like Tennessee, but this is a great story. They went out and printed up, they got the picture, made real T-shirts with that on there. They sent him one, or they sent him a bunch of gear, and they sold them. And all the money they made for it, they put in a scholarship fund. And there were like tens and tens of thousands, maybe even more, of money they made off these shirts.
Who is this
That's
for?
awesome.
I remember seeing that. That was so
Some
sweet.
kid, yeah, it was really cool
Because he
gesture.
didn't have
Oh,
enough money to
yeah,
buy
the
real-
Tennessee thing.
Yes.
Yeah.
Jonas said
I wonder how much money. Let me see.
it's not very good to be honest, but you know what we're having? I mean, when I say it, you might say yeah, because take it off.
Yeah. So,
Oh my God.
But you know, also I like that rubber. And like instead of like writing after, I was just like doing the exact opposite of what I'm supposed to do. Like a whole bit. Yeah, exactly.
I was like sitting in AP State and
I guess that's what I was feeling at the door. I wasn't dressed. I slept in.
Okay, different story. They sold 50,000 shirts. They sent him a big box of beer, like so shirts, sweatshirts, whatever like that. So they didn't give him the money from the proceeds, but they did scholarship him. So he has a free tuition scholarship whenever he wants to go. Class of 2032.
What if he just like didn't go though?
I do math. This is class of what?
this kid
So
is
10 years. He's
4 years younger than my sister.
So we kind of often know if he like changes his mind.
class of
like,
2032.
second grader.
Well, that's college 32. So he'll graduate in 28.
My sister's age.
So he's 12.
Sixth grade.
Yeah, 6th grade.
Remember when that went viral?
Yeah, I did too.
Is Tennessee higher up there in terms of price?
Southeastern schools, other than Vandy, are probably pretty similar. Vandy's a private school; it's the only private one, so I think they're all pretty similar in terms of tuition.
Was he in-state or out-of-state?
Well, if he has a scholarship, it wouldn't matter. But that's I don't know if it says that here. No, he's a Florida kid, so that was probably part of the reason he was bullied. I mean, UT and Florida are like have always kind of hated each other.
Tell me when I mess up.
My dad went to, he's from,
I'm probably
one of my national, from like second grade on, and then, he went to
I might do
like the
what I might
University
do
of
next year is do
Florida.
AP.
Yeah,
And he said.
So I didn't know that, but I do know that school.
Yeah. I think it is. It's really fun or whatever. He'd be like, oh yeah, there's college students graduating driving their Mercedes, and it was just.
Oh, Nashville's got so much money. And those private schools around Belmead and Brentwood and all those areas, it's insanity money.
Like, I was in my grandparents' house practice driving, and I got so scared. I was just like driving, I went casually sitting open the noise driving. I was like,
Oh, okay. What happened?
Oh, Tesla, Lamborghini, Ferraris, Mercedes. I mean, it's shit. I remember my wife used to teach. I mean, when we first, right before we got married, she was working for a church there, and she, Christ Press.
That's not how I did. I did extra
There's a Christ school there. What's it called? That's something. Anyway, it's a big Presbyterian church there. She was working there on staff with the youth there, and she was also working with Brentwood Academy and stuff like that. But we wanted to go on a picnic. You're good. So we're looking around for a park. Okay. So we're looking for a park, and I remember driving up to this lovely park, beautiful trees, everything. I was like, why don't we just have our picnic here? She's like, that's not a park, that's a front yard. And I was like, what? I looked way back, and I was just like massive.
oh my goodness.
But that was Belmead. I mean, it's just insanity money.
I remember like, my grandparents live in Sugar King,
Wait, I
we
can
drive
just
by now,
make this.
and it's just like $5 million massive houses. And
Oh,
it's
yeah, or
just
more. I mean, it's nuts.
It's insane, and
Yeah.
we'll do like, that's new, what in the world?
And you just drive through Brentwood, it's everything's million or
Wait.
more.
Espresso beans.
All right, I want to try one.
Yes, you should.
Is it dark chocolate?
Yes.
Mhm.
But it's not bad. It's not bad. Like I
My
don't
wife
like dark
loves dark
chocolate.
chocolate.
It's good. You don't like dark chocolate? No. We're
I'm not
good.
a huge fan.
It's pretty good.
Oh, those are.
All right, that's good.
Yeah.
No, I'm not.
Okay.
I'm not.
What are they? May I have one?
Espresso beans. Yeah.
I love those.
Okay, I don't need a ton of people.
And that's just it.
All right.
It's coffee.
Soup? And there's better ones at Publix.
Well, and you can have like one. It takes a little bit of the edge
It
off.
tastes so good. What the heck?
You know, for me, that's good because I don't want to. I'm trying to continue to lose weight. I think I had 1,100 calories yesterday.
Okay, Mr. Hurd.
Really?
I could never.
I had like 3,300.
Somebody told me there's a place called Crumble.
Oh, yes, that is so good. It's by my house.
The big cookies there are 2,000 calories.
Wait, where's
For one cookie
They are.
at Crumble. That's what Sam Sutton was telling me.
I don't think that's right.
order?
Yeah, maybe like a full order of foods. It's like 12.
11 letter to end in what?
There's no way. I don't believe that.
I don't know.
It might be like 4 cookies because they come in
You
like
put enough
different
fat,
sizes.
but it's also lard and butter and sugar. I don't know.
Wait, look at it. It's like by the city center.
Yeah, that's what I've heard. I just heard about it yesterday.
Wait, so that's the first time you've ever heard about Crumble?
Never heard of it
I've
before.
heard her talk about it.
Me? Yeah, I can talk. Oh, yeah. When did you get your license?
Hopefully.
Yeah, girl, you have not been driving.
No, they're like, actually, no, they're like between 500 and 700 calories per one.
Well, that's what it says. Okay, he was exaggerating.
Hey, yo, boss.
This is how many?
You can?
Her serving is 30 grams, which is.
Oh, yeah. and-
5.75.
Alright, now let's go.
In Florida.
Butter is 5.75. Chocolate chip is 7.
Okay.
Oh, wait.
So it's probably talking about a full set, which is 4 cookies, so that's probably what it means.
All right, check this out, guys.
Our scores back there's no.
No, you're right. There is no way. Yes. Now the COVID curve.
Based on what you said, I was like, COVID, check this out.
Oh, we need to know the like eyes
That,
and everything.
right? Look at that.
I don't have it.
646 in the entire state. And to put that in perspective, look at these numbers. 470, 480, 580, 440.
Alrighty.
Bam.
I see you.
Nice. So I'm thinking there's a shot that Friday will be under 1%. And if we are, we got one more makeup mask. But if we're not, I really think next Friday will be. Unless there's some freakish outbreak, which you never know.
I mean, you never know. Rose Parade happened and then most of us got knocked out, so.
Yes. I've always predicted, I thought 4 weeks would be the low end. So if we are under this Friday and next Friday, that would be 4. I thought 6 weeks would be the high end,
That's what I was thinking.
but I was thinking 5 would probably be. But based on this, I mean, that's really low right there.
Yeah, like our friends are basically all of us have gotten it. Like from Vancouver.
Even the people that haven't got it might got it.
Yeah, they probably don't know. Anyone that
Yeah.
hasn't had it, they probably got
There's
it.
tons of people that have it and aren't. Like how many people in sports have been positive and have shown no symptoms, but they still have to quarantine whatever. So tons of people. If you're not if you're positive, you're not showing symptoms. You're not getting tested in high school, unless there's some big event you're doing or something. So
Yeah, because if you're not positive, you can still be positive with PCR tests are awful for detecting it. So.
true.
I was negative.
Yeah, I was positive on my test, but my wife was negative, and
Oh,
I mean she's around me all the time.
PCR, they called it early, they said you're negative, and we were like, oh, we don't believe it. The next morning, they said, actually, yeah, you're positive. And I was like, no,
I think it's gonna be yeah, because the weight test is like accurate at all. It's like accurate 50% of the time, which is literally pointless for a quick test.
I wonder what's going to happen in like 10 years when they finally figure out what's going on, and they really have some. Like there's video of Fauci saying, well, you know, if you have AIDS and you get too close to somebody, it can be spread that way. I mean, literally, there's video of him as a younger man spreading that because we were ignorant. Just like I'm sure half the stuff that's out now is just based on fear and not ignorance. I mean, we'll know in 10 years maybe. But literally, they have the guy in charge of science saying, don't get too close to somebody because you might catch AIDS from it. Yeah, this is back in the 70s, late 70s and 80s when the epidemic, nobody knew anything about it. People were so fearful. Like, I remember that fear. Can you use a public bathroom? Oh my God.
We told us to beat you.
So
I
we
remember we used to straight out and road trip before we like got in, like at the beginning of COVID, we didn't do that.
Well, I remember Magic Johnson. He's still alive today. Got was positive for the HIV virus. So he tested positive. Quit playing pro basketball. He was like an all-star, a Hall of Famer. Quit because he was afraid he would give it to somebody. I mean, one of the greatest basketball players of all time, easily in the Mount Everest of college, in top 10. He's quit. Magic Johnson. No, when he got tested positive for HIV back in the day, and he's still HIV positive, but he's treated it. He's still alive, functioning greatly, but he quit playing.
Oh yeah.
And he came back once after a while. Like he quit playing for a few years, and then he played on the Dream Team back in '96, maybe.
Yeah.
But he quit. Imagine like right now if Kevin Durant got COVID and went, quit playing basketball because I'm afraid I'm gonna give it to somebody. I mean, it's almost, that'd be such a loss, but that's what happened because of fear and nobody knew what was going on. I said if there's going to be one, it would be one of the imaginary ones, but it's really the same thing, but where here we do A plus BI, here you do, I use XY, but you can use AB, you go A plus B root 5. And then you do the same thing, you square both sides. Here you put the I stuff together and the non-I stuff. Here you put the root 5 stuff together and the non-root 5. It's the same thing. The only difference is at the end of these, there's two answers like you have here, but one of them's negative. You gotta, and you throw it out. Yeah, but no, if I give you one, it'll be the one with the I. No, maybe 42 tops.
42 problems?
Oh, no, there's like 6 or 7 problems.
Oh.
Maybe 8, something like that.
I love the number 28.
No, you're
Your second favorite number.
Yeah. My favorite number is 31 and my second favorite number is 28.
Mine's
What about you?
18, 13.
29.
What?
It was right. Is that would be how many years I have when I retire? No, I don't have a favorite number.
Wait, hold on.
Wait, so what's your second favorite number?
I don't know if I have a favorite or a second favorite.
You don't have a second favorite
I don't know.
Oh, it's really funny because number 31 was like my favorite number for a while, and it turns out that was my dad's football number when I was like in high school or middle school.
Yeah, I used to love 5. I always wanted 5 as my baseball number.
That's a pretty good number.
Yeah, it always looked a cool one to me.
It is a cool number.
Yeah, but I don't know that I've really thought about it.
18 and 13. I think 13 and like 13 only.
That's why I think that's
It's
why.
underrated. It's got a bad rap.
I think that's why I did 30 because I don't know why it's my favorite number, but I've like had it as my favorite number for a while, and I think it started because it was like backwards from 13, 31.
18 plus 13 is 31.
Whoa! So like my I'm so confused what I did. I don't know where I did.
Look at it, like, great is good to think. The risen. This is me. Yeah,
It doesn't work. It's delicious. Laugh that.
I won't say anything.
Oh wait, it's because I combined two.
You have, I have to hold it. Just smell it.
Okay. I was like, what? This equation is nowhere on there. I'm like, it's an equation I made. I think I'm special. I did That is a good. You know what I also do is like where you put your legs up on the wall, like you lay down and like that's a good stretch. I did that this morning. It's very nice.
That was my favorite part. It's like,
I like forget all my stretches, and then I like see it on a YouTube video.
Okay, if you ever get a stretch.
I probably will, to be honest. You know all the best
I know.
stretches being the day
It's
episode.
there,
That's like
well, it's there.
half of your time spent like with warm ups. Guess what? Jazz told me this morning.
And then this is what Lotus said.
And
Like, I'm not even kidding.
Like, I don't plan on doing it.
No. Oh wait, I'll tell you in a second. Well, yeah, I'll just tell you. Well, no, well, like not like that. Kind of.
You know what you
It's funny.
I just said.
What's your point?
Oh wait, I'll just go like text you and I'll text it to you. I'll just like check it out. Yeah, exactly.
Our bonus is.
Well, yeah, or I don't know.
We haven't seen.
Not for like that reason, but.
Like I didn't try to find it.
Wait, did I tell you?
It was easy.
I didn't want to do it. Well, actually, I was like, I'll do it at the end. And I forgot about it.
Girl.
I forgot about it. We waited for
It's kind of cute though. It's like a little tiny.
I didn't get caught.
Yeah, I don't think it's possible.
Oh, actually, what's the word? Like, wait, I didn't hear about that. No, I didn't get caught. I just said that like what happened was my article died.
My doctor. I don't care that my phone is not doctor.
Which is weird is I put.
That's what I do anyway. Like I still have pictures and I have to like done these things.
Because my mom likes to take.
I mean, it's not. It's also true because I typed it in wrong and then it autocorrected.
That was the worst thing it's been.
So like,
She just got it.
right.
It's a good order. It just like
I'm
folds
it's like nothing after the honor code.
Well, I don't even do
I'm
anything.
gonna like throw away in the lunchroom so I can still like
Just
try
forward
as
your,
I bring down my cups of coffee.
signature on the honor code.
So you didn't get away with it.
I will.
Yeah, I've grown. That was like the first last season. I've been changed, man.
Oh yeah, she included my backpack in it. Because I have a basic backpack. She goes, Pete,
Right.
yeah, she goes, POV, go to American school. And she shows my backpack in it.
It's not even important. Yeah. I forgot that I wrote mine in this week. That's why there's nothing.
So much.
And I was like, oh, I don't think this comments is a little flashlight thing. You can see what I actually wrote. So I had to. I forgot what I.
Like it doesn't look too bad, and then you show me next to you. No, I'm wearing an arm. Like I'm a lot lighter.
Are you doing
Well, actually, my arms are pretty tan too. So my stomach, I'm not gonna show my stomach right now. It's like so pale compared to my face.
That's why I take you.
Mine's just full of, I thought it was just full of expression.
You can kind of see like where my ear is.
Me is actually Miller and the rest of them were fresh.
But actually, since I'm using my tinted moisturizer,
How is it? Let's go.
but his hairstyle's so good.
The first time we
What?
what? The second 9 weeks we
How did I
met.
not know this?
Here.
Harry Styles' birthday. Oh my gosh, oh my gosh. It's today. My day just got so much better. Oh my god, I need to make my birthday present for Harry Styles.
No,
Anyway.
the building was the best part. You could actually
Why 2 minus 2?
Wait, is it his 28 too?
That's not gonna be on your test, but the bottom line is when you squirt, you're not supposed to talk to the test.
Oh my
like
god,
that.
I'm literally doing that.
When you split, it's not on the test. When you squirt, a number can never be negative.
I can get tested.
So when you get to the end, these aren't negative because it was imaginary. They don't really have a negative value. Because those don't have an I. So negative 2 plus 3 root 5 is a positive number because that's bigger than that.
Oh yeah, I need to
Right?
confront
But
this
if you
Harry
have
about this.
positive 2 minus 3 root 5, you end up with a negative number. And that can't be negative. because you square
I
it.
know there are 2 bonuses. I don't know.
So you always got to throw one of them out when it's got a radical. When there's no I, you're gonna have to throw one of the final 2 out.
Let's confront Mr. Hurry. Okay, Mr. Hurry, on number 6 on the homework, you made it 11-6. You could have made it 12-6, and that would have reduced the 2. But you had to trigger us all and make it 11-6 on the homework.
Yeah, probably wouldn't think.
Because we're people I don't like.
That was a little bit
I like
harsh. You kind of came at them.
Sorry. Because I was very upset about that. I know, I was like going off last night. Like so much just like that's triggered. Okay. Okay. Anyway, I definitely need to drink water and hydrate. You need to
Oh yeah, Mr. Barry, so far my garage has not been set on fire by
Hold on, I
gasoline.
gotta go.
You what?
My garage has so far not been set on fire.
Sweet. Fire's not good in the garage.
Yeah. I'm gonna bring this to you.
Either you or just need coffee.
That's true though.
Oh my, I said coffee. I said you weren't getting coffee over there, and I'm like, yeah, no, that's not. That's funny. Let's go.
I mean, that's kind of.
I'm so mad at myself. I almost did your name perfect. I love it. I'm so proud that you got my Japanese name right, but you got my English name wrong. Like,